everyone, we are Team Virtual Eye, Team ID 107. We are from BNM Institute of Technology. My name is Shama.
I am Prithvi.
I am Hitesh Viharitas.
I am Sujay Jain.
We are developing a blind assistance device called Virtual Eye. Current estimated facts state that there are nearly 285 million visually impaired users, of which 39 million are blind and others suffer from low vision. Approximately 90% of the people who suffer from blindness are from low income backgrounds. The main aim of our project is to provide an efficient platform to enhance the perspective of the surroundings to the visually impaired users. This is achieved by using the concept of image processing, segmentation, and feature extraction along with a database which consists of prefed data of images which aids in the recognition of image captured, also keep the financial perspective in mind.
A head-mount camera is used to capture a video on a real-time basis whenever desired. The video captured is processed and compared with the information stored in the database and alerts the user with an audio output with a haptic feedback of the same. The camera is placed over a maximum field of vision to eliminate the blind spot to a greater extent. The effect of blind spot is overcome by the grid technology that senses the variations in the surface gradient and reports the data to the user.
The TI components used for this project are the BeagleBone Black, an embedded system with a Sitara encode processor, an open source multifunctional hardware used to perform image processing at a hardware level. The LM386 audio amplifier interfaced with the BeagleBone to enhance the audio quality of the output. The Logitech HD webcam that records HD videos for live video and image processing.
Head-mount camera. A Logitech webcam is utilized to take real-time image of the surrounding object and transmit the data to the CPU. The camera has a viewing angle of 120 degree as shown in figure 1. BeagleBone Black. BeagleBone Black along with central processing unit is used to process the image obtained from webcam and recognize the captured image from the database, the output of which is given as a haptic feedback and an audio signal as per the needs of the user. Text-to-speech. The TTS module is used to convert text data stored in database for a particular image to audio format. Haptic feedback. The system helps in providing vibratory sense whenever audio signal becomes a hurdle. For example, in traffic junction where listening to surrounding plays a vital role in terms of safety. Speaker or headphone. The audio signal is amplified by means of audio amplifier and is output by means of speaker or headphone as per the needs and necessity of the user. On executing our MATLAB code, we get an option either to choose webcam for real-time video processing or prime location identification using GPS coordinates. First, we will demonstrate the identification of location. For example, if GPS coordinates of the institution where the visually impaired user studies is stored with a code value of 10, the corresponding output as a result of image processing is as shown in the recording.
BNM Institute of Technology.
Similarly, we have demonstrated for his workplace, a hospital, and a holy place.
You have reached St. Thomas Hospital. This is your workplace. This is a Hindu holy place, the Madurai Meenakshi Temple.
Now, moving on to webcam for real-time feature extraction. These features can be activated by selecting the option 1. We have programmed 4 main features, namely vehicular motion that keeps count of approaching vehicles as demonstrated in the following sequence.
Two vehicles approaching. 3 vehicles approaching. 2 vehicles approaching. 1 vehicle approaching. 1 vehicle approaching. 2 vehicles approaching. 1 vehicle approaching.
The second feature of Virtual Eye is human motion detection, which senses the movement and aids the blind in places crowded with people such as market and pedestrian walkways. This feature is illustrated as follows.
Motion detected.
Face detection is a feature which enables the blind when he encounters a stranger. The process of identification of stranger's face is demonstrated as shown.
Considering the recommendations stated, the team visited Sri Ramana Maharshi Academy for the Blind, JP Nagar, Bangalore, and inquired about the problems faced by them in everyday life. We got valuable inputs from the VI community regarding the failings of existing blind assistance devices. To quote a few, negative effects of range in existing smart canes. The error associated with high-range smart canes is of practical nature. In a situation where an output is produced due to an obstacle existing far away from the user may confuse this to be from a nearby object. Obstacles of greater height. The use of a cane aids in detection of obstacles in proximity to the ground. The risk of colliding with an obstacle at a height considerably above ground level is high. The field of sensing obstacles is restricted only to a very small radius, which is one of the major concerns for the visually impaired. They cannot rely only on audio output of the device due to the presence of external sound. An audio output alarming systems help the visually impaired person in a low noise environment. In case of an environment with high noise from multiple sources, example crowded places, markets or junctions, it is natural instinct to judge incoming danger by listening to the surrounding noise. Thus we overcome this flaw by using a vibratory sense or output volume control. Virtual eye can be alternatively used by aged people with low vision, in automated cars for self-assistive drive, in military modules for detection and mapping of enemy terrains, and can be used as a low-cost security system in metropolitan cities.